Continuing to look on this latest subject, sinuous meandering rivers at canyon bottoms. Grand Canyon. If the bed, Grand Canyon and all these other canyons, especially in Utah and elsewhere, if the bed is subject to down cutting at all, it will be eroded rather than the banks, the bed, the riverbed. The banks, since the greatest tractive, drawing, pulling, adhesive friction stresses are directed along the bed rather than at the sides of a stream. It goes down first and then spreads out. A stream which is degrading its bed tends to straighten its course, with sharp radius bends being eliminated by cutoffs because of the huge amount of water. So water tends to erode river bottoms first. Let me repeat. Water tends to erode river bottoms first. Goes all the way to bedrock. Grand Canyon, it's not millions and millions of years, hundreds of millions of years, as it gradually goes sideways. It goes down really hard and fast, then spreads out, full blast of water, not gradual processes, and everything gets wiped out, and you have a canyon formed in a matter of hours. So water tends to erode river bottoms first, two river bottoms first, straining the river's course until the river bottom becomes relatively resistant to erosion. Then the water turns and tends to cut laterally into the sides of the river, forming a meandering course whenever the banks are soft and susceptible to erosion. But the problem with claiming that canyons are caused by years of erosion, so that there are innumerable and highly winding deep canyon rivers, which have always had extremely resistant river banks, these banks being composed of solid rock all the way down. Now, everything loose. I mean, we see this over and over again when we see small canyons like the one up in Northern California, which formed in like 9 hours. That wasn't lots of erosion over millions of years because people saw it the way it was the day before. 9 hours later, when it started, it's a canyon. Thus, how the courses of these deep canyon rivers got to be so winding cannot be explained by the uniformitarian principles of years and years of erosion. I had to say principle of years and years. Well, I think there are a number of principles involved, and that's why they claim years and years go by. Picture an immensely large flat area, a plain covering thousands of square miles, which we're looking at, completely covered with water. This immense plain is then uplifted by unimaginably great underground forces, causing the water to rush off with immense force, taking with it loosely packed sediment deposits wherever it flowed. This sudden and massive draining away of an immense amount, just think of the Grand Canyon, of the loosely packed sediment left behind a newly formed canyon of hard rock with erosion-resistant winding canyon sides and a meandering river at the bottom. Grand Canyon, where do you find some soil, loose stuff on the sides of that huge canyon? Nowhere. Why isn't it continually, gradually trickling away? There's no erosion at the Grand Canyon rock sides, visible now happening. On a smaller scale, picture a slope of loosely packed dirt which is heavily rained upon. After the rain, there remains many miniature canyon-shaped grooves carved into that slope where streams of water tore away the loosely packed dirt. See this in San Diego all the time. Big ruts. We hardly have it rain here. When it does, you see these canyons, small miniature canyons, shaped one way, and immediately the next day they have ruts flowing according to the way the water ran, completely changing the picture of that area. One trough is here, it's bigger, one trough is smaller, it meanders one way or the other quickly. After the rain, there remains many miniature canyon-shaped grooves carved into the slope where the streams of water tore away the loosely packed dirt. Some areas of the slope remain untouched, while others have deep grooves worn into them, shaped similarly to a canyon, some having straight courses, some meandering. This would happen. You experiment this way. You put loose dirt in one place and another. You put some clay in another place and see how it works. This would happen. The causing of meandering river courses. In fact, even before the alluvial blanket, the blanket of loosely deposited sediment was eliminated, and certainly no substantial amount of lateral shifting could be initiated once the stream had cut down into bedrock. Intense meandering, when slopes and velocities are high, would require that the bedrock be extremely resistant to erosion, so that excess energy could be dissipated in no other way than by lateral cutting. But if this be so, then the deep meandering gorges could never be cut. The familiar meandering pattern of streams in alluvial valleys primarily results from a small stream gradient inhibiting further down cutting and weak banks permitting side cutting by local curvilinear water motions. Occasionally, however, strong meander patterns are found in valleys of steep gradients and strong rock banks, such as in the San Juan River in Colorado. This anomaly is commonly and falsely attributed by geologists to a former alluvial blanket of water deposited sediments that supposedly once overlaid the rocks and since has been eroded away. The meander pattern is said to have developed in the normal way on the alluvium water deposited sediments and then entrenched in the underlying rocks when the region was uplifted. However, such an explanation is highly questionable in terms of known principles of stream mechanics. It would seem that the only way in which such strong lateral cutting could take place simultaneously with down cutting would be for the banks to be less resistant than the bed. And this implies that most of the meander formation must have taken place when the horizontal beds were still soft and the unconsolidated soon after deposition during the flood period. Things take time. Bigger waves come after smaller waves, or vice versa. It's all haphazard. Well, unless you were omniscient like God, you knew every little nook and cranny throughout the world, and you could tell exactly what was going to happen, and then what's going to happen after that. Nevertheless, such incised, carved meanders are a commonplace phenomenon in uplifted plateau or other mountainous regions. It would seem that some sort of avulsive flood origin for them must be postulated. Great systems of vertical fissures might be imagined, which have been widened, deepened, and rounded by subsequent drainage through them. If erosion processes must account for the complete excavations, however, then it would seem necessary to postulate much greater volumes of water in the streams than now present, together with much less resistant walls than the rocks of which they now consist. Ergo, we are back to a catastrophic flood of immense worldwide proportions. Remember, it's not just a go-through one time of a lot of water. It's go through here, go through there, slam together, go down, deposit stuff. Suppose two waves slam down, deposit, and go away. Then there's uplifting. Now something else comes down and takes all the way that the previous two waves deposited. That seems the name of the game. The worldwide flood didn't happen 40 days and 40 nights in one stream of flood water after, and that was it. There's one stream of flood water, one after the other. Anachronistic mountain strata. In every mountainous region, on every continent, there seem to be numerous examples of supposedly old strata superimposed on top of young strata. Kind of what I'm hinting at. In the absence of definite structural evidence to the contrary, one would naturally suppose that the lowermost strata must necessarily have been first deposited and therefore be older. But the fossils often seem to belie this assumption, and it is the fossils which govern the assigned formation age, I say, according to evolutionists. Not according to me, because I'm no expert, but plausibility probably supersedes so-called expertise. As noted previously, the official explanation of this sort of anachronism is in terms of what is variously called an overthrust or thrust fault, low angle fault, nappe detachment thrust, or similar terms. They just make this stuff up and describe what might have happened. The concept is of a large section of stratified rock being elevated and which slid over on top of the adjacent rocks so that the older rocks at the bottom of the moving mass will then be on top of the younger rocks on the top of the stationary rocks. Subsequent erosion then is usually assumed to have worn off the younger rocks on top of the displaced topography. The problem with that is that's violent. Most of the time these are no violence around it at all. It is recognized that phenomena of this sort have taken place on a small scale in certain localities where there is ample evidence of intense past faulting and folding. However, these visible confirmations of the concept are definitely on a small scale, usually in terms of a few hundreds of feet, whereas many of the so-called great overthrust areas occupy hundreds or even thousands of square miles. It seems almost fantastic to conceive of such huge areas and masses of rocks really behaving in such a fashion, unless we are ready to accept catastrophism of an intensity that makes the Noachian deluge seem quiescent by comparison. Certainly, the principle of uniformity is inadequate to account for them. Nothing we know of present Earth movements, of rock compressive and shearing strengths, of the plastic flow of rock materials, or of other modern physical processes gives any observational basis for believing that such things are happening now or ever could have happened, except under extremely unusual conditions. Hubert and Ruby admit, since the earliest recognition, the existence of large overthrusts has presented a mechanical paradox that has never been satisfactorily resolved. Satisfactorily resolved. No, when they try to back out of this stuff that they can't explain, the vocabulary words get even longer and longer. How about we just can't figure this out? Hubert and Ruby, role of fluid pressure in mechanics of overthrust faulting. And that's his explanation. After the whole book, he starts to say, well, the earliest recognition of these circumstances, large overthrust presented a mechanical paradox that has never been satisfactorily resolved. Then why'd you bother writing the book? Try to explain it. If you haven't resolved it, wait till you get the resolution. Well, you need to make money. To illustrate the character of these important areas, we might consider the well-known Heart Mountain thrust of Wyoming. This supposed thrust occupies roughly a triangular area 30 miles wide by 60 miles long, with its apex at the northeast corner of Yellowstone Park. It consists of about 50 separate blocks of what they call Paleozoic strata, Ordovician, Devonian, and Mississippian, resting essentially horizontally and conformable on Eocene beds, some so-called 250 million years younger. How did that happen? Pierce shows many pictures of the fault line, all of them looking for all the world like any other normal contact between chronologically deposited strata, except the rocks took each other's place. They shifted spots. An even more mysterious factor is that there appeared to be no source beds from which the thrust blocks could have broken off. The Heart Mountain thrust has long been structurally perplexing because there are no known structural roots or source from which it could have been derived. You look around. Oh, that caused it. No, there was nothing. Furthermore, there is no known surface fault or fault zone within or adjoining the region from which the thrust sheet could have been derived. There it is. No, it's not. William G. Pierce, Heart Mountain